Here you go, sir.
Thank you for having me. It's great to be here. Like he already mentioned, I work at Red Hat, and I'm doing process migration, container migration for many years. I actually started with process migration over 15 years ago, and this was in an HPC environment. And then for the last 10 years, I'm mainly focusing on container migration. And for the last 5 years, I'm focusing on container migration in the context of Kubernetes. Everything I'm talking about today is related to a tool called Creo. I will just talk more about it in a minute. So whenever we checkpoint and restore a process or a container, the lowest level will also always be done by the tool called Creo. So, sorry. So, Creo. Creo stands for Checkpoint, Restore, and User Space, and there's a reason why it has the name Checkpoint, Restore, and User Space. Checkpointing and restoring processes is a technology which exists in computers and Linux for a long time. And especially in Linux, it was used for high-performance computing for many years, because the reasons were basically the same as they are today. You have something which is running a long time. You want to make sure it keeps on running. So you use something to checkpoint the state of your process, which means you take a stateful snapshot, you make an image of the process, write it to disk, and later you can use this image to restore it in case something fails. Some communication network goes down, or your compute node goes down, whatever it is. And Checkpoint Restore tries to work around this by taking regular checkpoints. And in high-performance computing, there were, I think, maybe 20 years ago, at least two different approaches. And those approaches were, they were never a part of the upstream Linux kernel. They were also always available on the side, so you had to do additional steps to make it work. And the other approach was you had to prepare your process. You had to LD preload a couple of libraries to intercept system calls. And so this always meant that in checkpoint restore speak, the checkpointing and restoring was not completely transparent. So you always had to know before doing a checkpoint, when you start a process, you have to prepare the process in some way. And that's the reason why around, I think it was maybe 2005 or 2007, something like this, there was an approach also coming from high-performance computing, which tried to implement this whole thing in the Linux kernel. It was a huge patch set, over 100 patches, and it was working at the time. But the Linux kernel community was not totally convinced. So it existed, it worked, but it was never merged by the Linux kernel community. And then, because that approach was in user space, that approach was in kernel space, the next approach people tried was in user space, checkpoint restore in user space, Creo. So that's why we have the name, because of the history of previous approaches. And the goal from the beginning of Creo was, Creo tries to do as much as possible in user space, and it uses existing kernel interfaces as much as possible without having to extend the Linux kernel. Over the years, the Creo developers introduced additional interfaces into the Linux kernel, and they are not 100% only used by Checkpoint Restore. They're used by many other different technologies, and it's mainly always about getting information from a running process so that you can more easily debug it. And that's also how Creo works. It gets all the information about a running process, creates the image files locally, writes it to disk, and then later this information can then be used to restore the process and run it on the same system, run it on another system, or run it multiple times. And the nice thing about Creo, in contrast to all the other approaches which we had before, was that Creo was developed for containers. So that's also the reason why today from what I know, Creo is the only tool which is used for container checkpointing and container restore. So now let's go to the container environments. So when there's a very early ticket from Kubernetes where people were asking from 2015, so it's over 10 years ago or old. People were asking, how can we migrate a container from one node while it's running to another node? And this is basically the same thing you have with virtual machines, because you can migrate a virtual machine from one host to another node. And the question was, is this possible with containers? And yes, it is possible. If you find this ticket, it has like has a very short number, so it's very early in the history of Kubernetes. It doesn't talk directly about CREU, but the concepts it talks about are similar to what we do today. Since 2015, I and other people, we have been working in the container environment and try to make sure that checkpoint restore works on the whole stack. The problem is we have to implement it on every layer of the stack. So what we first looked into was runc, the low-level container runtime. We also implemented it for crun, another implementation of the low-level container runtime in C. Then we worked with the Docker, with the Podman community to implement it there. We worked with the LexC, Incus community to also implement checkpoint restore there in container migration. And I mentioned already Docker, but for containerd, especially for the Kubernetes implementation, we also worked with the containerd community recently to get it implemented in all the layers of the stack. So 5 years ago, we wanted to make checkpoint restore available in Kubernetes, and the goal was to, one of the goals is to enable container migration. Maybe you have a command like kubectl migrate, or even something like, the scheduler decides because resources are getting low or a high priority job comes in, a low priority container, instead of killing it and losing all the work, we migrated it to some other compute node, some other cluster node, whatever it is. And the reason why it's called forensic container checkpointing, when we try to implement it in Kubernetes, we try to come up with a story around it, how we can bring it to Kubernetes, which makes sense, but also which gives us a way with minimal changes to the code base, because the technology is it's new and it's not what container people expect from a container, because the idea of a container, of course, it's stateless. And now we want to take a checkpoint. How can we combine these two ideas? How can we migrate something? Is it necessary to migrate something if it's stateless? The truth shows us that there are a lot of stateful containers actually running, so container migration does make sense. But the idea of forensic container checkpointing was, you have a container running, you think it might be under attack, but you're not 100% sure. And if you kill the container, maybe the attacker is then gone, you cannot trace it. So the idea of forensic container checkpointing is, we have a running container, we take a checkpoint, write a stateful copy of the container to disk. The container will never know that it was checkpointed. The container keeps on running, and now you can analyze the checkpoint offline. You can just look at the files, because now you have all the memory pages written on disk, you have all the registers, everything, all the changes the container has done since it started up. Or you can maybe start a container in a sandbox environment where it cannot connect to the internet or something like this. And you can do it as many times as you want, because you always have the checkpoint to use as a starting point. And this is something which people actually ask for, because there are certain intrusion detection systems running. I think at Red Hat we have a product called Advanced Cluster Security, and the Advanced Cluster Security people are interested in combining this with their already existing intrusion detection, so that instead of killing the container, we take a snapshot and then it can be analyzed without losing any of the information, why the container was attacked or from where. And so in 2022, we were able to merge this into Kubernetes. It was an alpha feature. Alpha feature usually means in Kubernetes it's turned off by default. And at that time, we only implemented it implemented it in CRI-O. This is one of the two container engines you can use. There's CRI-O and Containerd. And once this was working, we worked with the community to make sure that any reported bugs are fixed. And then in 2024, the feature moved to beta state, and now it means it's turned on by default. So if you today use Kubernetes newer than 130, you can do container checkpointing. You can even restore a container. We also implemented it after 2 years in Containerd because this was something the community requested from us to move it forward. Both container engine had to support it. So now I was talking all the time about container checkpointing because that's what we implemented first. But besides the forensic container analysis use case, and if you're interested in forensic container analysis, there are talks in the internet where we show how you can use the checkpoint files to analyze what was going on in your container. But if you want to migrate a container, we also need container restore. And this was we were kind of lucky to find a way how to implement it in Kubernetes. So what we do, so when you start a new container, when you run a new container, then Kubernetes usually does a container create and a container start. And what we did is we hooked into container create and container start to identify if this container is a checkpoint, and if it's a checkpoint, we do a restore. So the interesting thing here is the restored container is a restored container, but Kubernetes never knows it. So for Kubernetes, this is an image, please start it, and then it looks like a container, it just started, but the container engine below will know what to do and will do a restore. So it's a restored container, but Kubernetes doesn't know. So let's talk a bit about a couple of use cases. And all of the use cases I'm talking about today is used by people in production. So this is not as unusual it might sound. This is actually used by people in production. So the quick startup use case is what many people are interested in. So you have a container running on your host. In most cases, this is a Java container because the Java container takes a long time to start up. And what we can now do is we take a snapshot of the container once it is all initialized and write this container to disk. And then we can create multiple copies of the container which start really fast. So we have seen like 50% increase in startup time because we avoid all the library initialization. We just load all the memory pages into the right place, and then the container just runs without all the complicated library loading. It's just loaded all in one go. Another use case is container live migration. I mentioned this before. This is you have some host running your container, and for some reasons you want to get the container off that host. It might be broken. It might be needed for something else. So again, you can create a checkpoint, a stateful copy of your container, write it to some storage system, and then you can restore it one or multiple times on the destination host. For checkpoint restore and container migration, it doesn't matter if the original container is running or not. This is just something you can decide. You can say, I want to keep this container running, or I want to stop it when I do the checkpoint. So there's no difference in the technology. It just keeps on running or not. So what a lot of people are very interested in is spot instances, because spot instances are usually cheaper, but you have the problem they go away depending on the vendor in 30 seconds or 2 minutes. So you don't want to lose your workload. And so what people do today, they either do periodically do a snapshot of the container, and when it goes away, then it's just restored on another spot instance, and you lose the maximum of your snapshot interval of work. Or you can also do it when you get the evacuation signal, you can do the checkpointing. Then this depends a bit because writing all the memory to local disk is usually fast, but writing it to some external storage might take more time than you have to evacuate a node. So, and recently, lots of people have came to us and were talking about how can we use container checkpoint restore, how can we use checkpointing in combination with GPUs. And the reason for the questions around GPUs is that GPUs are really expensive and you want to use them as efficiently as possible. And we heard from very different users. So there's the Jupyter Notebook users who always wants to keep running their notebook and never stop it, but it's like 23 hours of the day it's idle and blocking the CPU. Then there is you running your training workload for your latest model and you want to continue running it somewhere else because this GPU is needed for something else, or again, there's some signs that it might be broken or something like this. And also what people talk to us about, and there are multiple startups working on this using the technology we implemented here is you have multiple inference users and you want to quickly switch between them so you can just suspend one inference workload and run the other one without keeping your GPU idle. And just quickly gonna go to my demo here, and it disconnected me. So in my demo, I want to migrate a container from one host to another host. Those hosts, both hosts are running on AWS. And the GPU is a small one because it's cheaper. I think it's an A10. I think I can, no. Yeah, what does it say here? I don't see it, but I think it's an A10. So currently there's nothing running on it. I have a small container which is running VLLM. I will now run this container. And once I send a command to Kubernetes to start a container, I have a script which is called container ready, which is just a loop to test until the container is running so that I know how long it takes to start up the container. So this will take now about 40 seconds for the container to be ready to answer questions, for the VLLM container to be ready. And if we look here, we see there's still no process running here. Now you see there's a Python process now running on our GPU. And now it takes some time to fill all the memory of the GPU, and then it should be at some point be ready to be used. So I said something about 40 seconds. Let's hope it's still around that time. Okay, and now I can talk to my LLM, and I can just. It's hard to see here, but I'm giving it the prompt. Here it starts here. Creo is a Linux tool, and I want the LLM to finish a sentence. And it's a very bad LLM because it says very funny things. So it's running, and the counter just says how many times I accessed it. And now I can create a checkpoint from it. No, this is the wrong command. So this will now talk to Kubernetes, and one limitation which is currently with container checkpointing in Kubernetes and which we want to address in the future is it's currently a kubelet-only interface, so it's not part of the API server. I will talk about that goal later, how we want to make it part of the API server so you can use it from kubectl at some point. So we already implemented it in kubectl. So it's not a technical challenge to get it to kubectl because it's just a forwarding of the API. It's just to figure out with the Kubernetes community what is the right thing to do. So what we are doing now, we are talking to the kubelet, and then the kubelet tells the container engine, Cryo in our case, to create a checkpoint, and then Cryo calls runc, then runc calls Creo, then Creo, okay, because it's a GPU code, then Creo calls the NVIDIA tool to checkpoint the content of the GPU. And this now happened, and now we're transferring the checkpoint to the second host. And then, so now the GPU has checkpointed it, then Creo does the checkpoint, writes it all together in a directory. Then we go to runc, and then we go to Cryo, back again in the level. Then Cryo creates the checkpoint information from the file system and packs it all together in one tar file. And this is the tar file which is then being transferred to the destination host. And once that tar file is created, then the checkpointing is finished. The changes we have seen with introducing GPU checkpointing is that now all of a sudden it takes much more time because there's much more content on the GPU. So now the container image is now transferred to the second host. It also, which one? No, it's the wrong one. Sorry. It disconnected my sessions, but this should be it. No. Okay. And if I just do a check here, get pods. So there's currently no pod running. Okay, now we can convert the checkpoint. Okay, the checkpoint was transferred from one host to another host, and what we need to do now is currently the checkpoint format is it's just a tar file which we can copy around, but to restore the tar file, we have to convert it to an OCI image. So this is currently happening, and once the OCI image is created, we can then restore the container from that OCI image, and then we will have hopefully live migrated our running LLM from one host to another host. So this might take a couple of minutes to convert this. So this is the demo. Just let's talk about the next steps we are planning in this Checkpoint Restore Kubernetes community. So we're planning to create a working group in the context of the Kubernetes community. So I think we filled out all the necessary paperwork. It's a pull request where we said what we want to do and why we want to do it. The reason why we want to make it in a working group, up to this point, it was a group of 3 or 4 people who were working together, but we see there's so much interest from different parties all around that we want to get input from all of the users of checkpointing restoring, especially in the combination with GPUs, and that's why we want to create the working group. And in the working group, we want to address the thing I mentioned. We want to extend the API from the kubelet to the API server, so we can use it from kubectl. We want to talk about pod checkpointing and restoring, because currently we only do container checkpointing and restoring. And the reason is that, especially if we want to migrate or have the scheduler integration, it makes more sense to have pod migration working. From our point of view, pod migration is, again, not a technical challenge, because we implemented proof of concepts there that we can easily create a checkpoint of a pod. So this basically is just a loop over all containers in the pod, and then we collect some metadata, and then we can move it to another host. Then we also want to look at how to integrate how to improve the checkpoint archive, because currently we have the tar file I was just copying around, and it's not the most effective way. It used to work when we were using non-GPU workloads because they were small. You didn't really notice it, that it took a long time, but with the latest usage of GPU workloads, it has gotten more difficult. And where are we? So it finished the conversion, and now let's restore the container. I'm just going to show you the YAML file, just that you see how it looks like. And it looks just like any YAML file you would give Kubernetes. And the thing is, which makes this special here is, where's my mouse pointer here? Is the image which I say, and this is not a regular container image, but this is a checkpoint image. And so for Kubernetes, it looks like a regular image, but for the container runtimes engines below, it's a checkpoint image, so it can do the necessary things to do the restore. And now let's restore the image, restore the container. And the nice thing is, if we now see the numbers, if we go back to our original screen, we see that the cold startup of the container took us 38 seconds. And the restore usually, this is a live demo, so who knows, but the restore is usually faster. So, which is a nice thing to see, that It's actually, now you see the GPU says now the process is now running on the GPU. And so restoring an LLM from a checkpoint is actually faster than starting it from scratch. And now let's have a look at if it still works. So again, I'm using curl to talk it. This is my prompt. Creo is a Linux tool, and I just want that it finishes the sentence. And again, it's not useful because the LLM, I think it's too small. I think this one, I like this one. Creo is a Linux tool for Windows. This is totally wrong, but whatever. So, okay, so I showed a demo how to migrate a container with GPUs. And if it's with or without GPUs, the migration looks the same. The thing which is needed for GPU migration is basically we need support from the hardware vendor because Creo can talk to the Linux kernel and figure out everything about the process, but Creo doesn't know what's going on in the GPU. And so AMD came along and NVIDIA came along, and they both provided different ways, but ways how to extract the data from the GPU, because we need to extract all the memory pages, all the registers, everything also from the GPU. And this feels like something only the hardware vendor knows how to do, and it's only working if the hardware vendor helps us. And with this, I'm the end of my presentation. So the summary is, this is Checkpoint Restore was first mentioned in 2015. The alpha was in Kubernetes in 2022. We had a beta since 2024. GPU support appeared this year. We showed it at KubeCon if you want to see a video with more details. And we're currently working on the Checkpoint Restore working group to make this more formal, more official, with input from more people. And with this, I'm at the end. Thank you for your time, and